All right, so standard form of a quadratic, it is f of x or y equals ax squared plus bx plus c. All right, so what do we know? Well, we know that this general graph is going to look like a U-shaped curve. And what do we call that U-shaped curve? We do call it a parabola. Parabola. All right. Now, every time you have this U-shaped curve, you have a vertex. And if your U-shaped curve opens upward, the vertex is at the bottom. So we would have a minimum. And if so that's a minimum. And if your graph happens to open downward, we have a vertex at the top, which would be a maximum. What goes through every vertex? What's this dashed line represent? Yep, the axis of symmetry. It is a line of symmetry. And it's always that vertical line, and it's always going to be x equals. Okay, so it's going to cut right through here. So let's talk about this. How do I know how to graph this? What's the information that helps me start graphing this quadratic that is graphs as a U-shaped curve called a parabola? What would I need? What are some of the facts we used? I mean, we just talked about some of them. How do I get even started on this? How do I know where my graph needs to exist and what points to pick? The y-intercept is an extra point that can help me. So if I knew that, I would put 0 in here and I would look for that c value. That is an extra point, but that could be really high, really low on the graph. It might not be part of the graph I want to see. What part of the graph do I want to center on? The vertex. So how do I find the vertex? Well, there it is. So in order to find the vertex, I'm actually going to start with the axis of symmetry. That's what you were rattling off back there, right? The axis symmetry, we do want that x equals, though. X equals negative b over 2a. So these ideas should all be in your head. We just need to bring them back and recall them from the back of that file cabinet and bring them back to the front. So the axis symmetry is x equals negative b over 2a. It is a vertical line that cuts through that x value of the vertex every time. So the axis symmetry is found using that formula. Now, why did we find the axis symmetry? It gives us our anchor. So if we were making a t-chart, the axis symmetry we would put in the middle. It helps us find our vertex. So let's talk about that vertex. The vertex is an ordered pair xy, but the x value comes from the axis symmetry. So the x is negative b over 2a, and the y value, you would take that and you would plug it back in, and that would be your y value. So you might see it written as f of negative b over 2a, and that seems really intimidating to students. Guys, if x came from negative b over 2a, then the answer for y comes from the function with that x value in it. That is all that is saying, but it looks a little scary. Okay, so whatever your vertex is, we always put smack dab in the center of our t-chart. And then you had mentioned the y-intercept. The y-intercept is a nice point to use if it's a good part on our graph. It was an extra point to use. Now let's talk a little bit about how if I know if my graph opens upward or downward. Do you remember that? What tells me if my graph opens as an upward facing U or a downward facing U? Yeah, if the A is negative. I like that you didn't say if it's, but then I heard someone else saying about negative. So if the A value is positive, or it's a positive AX squared, that means my graph is going to open upward. Now, if I can visualize my graph opening upward, that helps me. Because my graph opens upward, that means my vertex gives me the minimum. Vertex has a minimum y value. So I would know if I have a max or min just by visualizing it. Now, if I have a negative ax squared, that's going to make my graph open downward. Everything you square is positive, and we're going to multiply it by a negative number. So now it's going to grow in a negative direction. So we've got it going downward. So picture it going downward. Now it's a maximum value. So vertex has a maximum y value. Okay, so let's go ahead and put our facts to use and let's do an example. So I'm just going to break my page in half here. Here's your example. F of x equals 2x squared plus 5x plus 4. Without graphing it, without doing any algebra, what can you tell me just by looking at this function? It's in standard form. What do you know about the graph just by looking at it? Okay, it's going to be upward because a is a positive 2, so it's going to look like this. Knowing that it's upward, what else can you tell me? Yeah. It is going to be more narrow. We're going to talk about that more when we talk about vertex form, because that 2 is multiplying whatever you squared, so it's going to be a vertical stretch, so it's going to look a little skinnier. I know my graph opens upward, so I can tell you it has a minimum, can't I? I can tell you the domain. All parabolas open upward or downward have an infinite domain from negative to positive infinity because they get wider. But I can't tell you the range because I don't know that y value, but I would know that it goes to positive infinity. So I know a lot just by looking at it. Now let's get the facts. So let's go ahead and start with our axis of symmetry. Using our formula, it's x equals negative b, so negative 5 over 2 times a. I'm going to clean that up using my brain. If I need my calculator, remember we had to be careful. And I just like to leave it as negative 5/4, but if that bothers you, that is the same as negative 1.25. Okay, so that gives me my anchor. So I'm going to sketch a graph over here. It's not going to be the most accurate graph since I'm not spacing it evenly. All right, so here's my start. Now, I really don't have any points to plot. What I'm pointing is my axis symmetry. So here's negative 1.25, and there is my axis of symmetry. So I know that my vertex is going to hit somewhere here. I know my graph is going to open upward. So the next thing I'm going to do is my vertex. And I already know that it's negative 5/4, or if you don't like that, negative 1.25. And to find the x value, I'm just going to plug it in. So that'd be 2, and I'm going to go ahead and put in the decimal. I don't know, whatever you want to put in the calculator is fine. So 2 times the x squared using parentheses plus 5 times the x plus 4. So taking my calculator, I don't want to use my brain for this, and I'm typing it in. Clear. Okay. Not sure if you can see that, maybe. All right, so it is 2 times that negative 1.25, close parentheses, so the square is on the negative sign too, and just put in the rest of it. Again, you can use fraction or decimal, and I got out 0.875. Okay, so that is my vertex, 0.875. So now I know where my vertex is, negative 5/4, 0.875, just below the 1, and I'm going to go ahead and create a t-chart. Now, what goes in the middle of my t-chart? My vertex. So that negative 1.25, 0.875. And the reason I'm putting it in decimal form, it's going to help us, I think, to think about it. I want some numbers smaller than this, so I'm going to just jump to negative 2 and negative 3. I want to use integers. I don't want decimals. And then I'm going to throw in negative 1 and 0. Here's what I want to warn you. We are so used to putting the vertex in the middle and then building and having that symmetry where the numbers end up being the same. That's not going to happen because this is 0.75 units away and this is 0.25. So we're going to have sort of some oddball numbers. Now, in the interest of me not going crazy, I am not going to retype this every time. I'm going to go back up to my old entry. I'm going to change it to negative 3, use my delete key to get rid of the other decimals, and change it out. So there's negative 3, delete what I don't need, double check I still have my parentheses and my plus 4, and that's going to save me time. So there we go. Negative 3 is 7. I'm going to go in here and put in negative 2. I think I've proven to you guys how easy it is to use your calculators wrong. So it's really important that you're trying this with me. Negative 2 is 2. So don't assume we're going to get the same number. Put in negative 1. You'll see it's very different. I get out positive 1. Put in 0. Now, I mean, I can get rid of the negative sign. I could actually leave it. Put in 0. And I get out 4. Okay, so I'm comfortable graphing this. It's going to be a little bit non-symmetrical, but I think I'll have good points here. 2, 3, 4, 5, 6, 7. All right, so negative 3, 7. I've got negative 2, 2. I've got negative 1, 1. And 0, 4. There you go. There is my graph. Again, not the most accurate since I was sketching it by hand, but not bad. All right, let's talk about this. We said it's going to have a minimum value, right? What is that minimum value? What's the lowest point on your graph? It's that y value right here. Minimum value is not 0.875, but y equals 0.875. So let's talk about our domain and our range. Domain has to do with x, range has to do with y, right? So we said the domain, no matter how my graph opens upward or downward, it's always getting wider. Now, because we have a skinnier graph, it's going to take longer to get wider, but it keeps pushing. So the domain is always going to be negative to positive infinity. Now, this has a minimum value, meaning this is my low point, and then it goes up. So as it's going up, do we see that the low point for interval notation, the low is 0.875, and it goes to infinity. So without actually graphing that, all I needed was my vertex, and I could have told you the domain and range and the minimum and maximum. Okay, so next we are going to jump to vertex form. So flip your paper over, or grab a new piece of paper, and what's vertex form? Could you write it out without me, without notes? Vertex form of a quadratic. All right, so I guess see if you can do it. Do you know it? Any takers? I'll start. F of x, or y equals. No brave souls, huh? A times the quantity. It is x minus h squared. Nope, not c. K plus k. Yeah, so we definitely, A is used the same here, but we don't use B and C. We do use H and K. They do different things. Okay, so let's talk about A. What's A do? Well, I'll do this real quick. If it's a positive A, just like the ax squared, if it's a positive A times this square term, our graph is going to open upward. And I can visually see that I'm now going to have a minimum y value. All right, if I have a negative A, we already talked about this on the other one, same idea, it's going to open downward. It's truly reflecting over the x-axis. That's why it's opening downward, and that would give me a maximum y value. Okay, but there's more, and this is what I want to focus on. It's the idea, we talked about the absolute value of A, if it's greater than 1. So whether this is a 2 or a negative 2, a 10 or a negative 10, the idea is if it's positive, it's opening upward. If it's negative, it's opening downward. But whether I multiply by 10 or negative 10, I'm going to stretch my graph vertically or horizontally. Vertically, because it's growing. This is the y value equals this. Whatever you squared, you're multiplying it 10 times as much. So your y value is jumping. So it's going to look like a more narrow graph. So we call that a vertical stretch. So it could be upward or downward, depending on the sign. It's going to be a vertical stretch, or it's going to look more narrow or narrower. Okay, now, if it's between, if the absolute value of A is between 0 and 1, meaning a half, a negative a half, you're cutting the y value down. You're taking half of what it was going to be. So the y is not growing as fast. You're going to have a wider looking graph. It's going to be a horizontal stretch or a vertical compression. You're going to pull it to make the graph look wider. And when I'm talking about the graph looking wider, I'm talking, or skinnier, I'm talking about the parent function right here. That function of y equals x squared, where your vertex is at 0, 0, and 1 squared is 1, 2 squared is 4. That is what we're comparing it to. Okay, so talk to me about h. What's the h do?
Like where it is on the x-axis?
Yes, so it's going to be a translation, left or right. So these are all transformations, but when you're doing a shift, it's called a translation. Now I'm just going to say that is your horizontal translation or horizontal shift. Okay, so how many units? And we have to be careful because remember, it's x minus h. So we watch our signs. All right, and then k, what is that? That's your vertical shift. All right. So if we would take our vertex and shift it so many units left or right and so many units up or down, wouldn't that shift my vertex? So what would my vertex be just by looking at it? Instead of saying it's xy, we just say it's hk. You've moved it h units up, left, right, k units up or down. Now, with that in mind, what would be my axis of symmetry? You don't have a formula for the axis of symmetry here. That's different. Doesn't the axis of symmetry cut through the vertex? So if my vertex is hk, doesn't the axis of symmetry cut through that? So the axis of symmetry is x equals h, whatever that value is. Okay, let's do a quick example here. All right, so if this is my example, I have several things that are happening here. A is -2. That means my graph is going to reflect over the y-axis and be going downward. So I can picture that as having a maximum y value. I can also tell you that it's going to have a vertical stretch because the y value is growing 2 times as fast. Now, the h value is not 3, it is -3 because it's really x minus a -3. So that means it's going to move left 3 units. That's the shift. And the k value is 5. All right, so now that we talked about k being 5, that means it is going to shift up 5 units. So that's going to help me a lot because if I'm picturing my initial graph going at the parent function, I am now moving left 3 up 5 so I can visualize my vertex. So that's my next thing. Without doing any algebra, I can look at this and say if h is -3 and k is 5, that's moving my x value to the left 3 and my k value 5 is moving it up 5. So with that, I am going to create my graph. And I have a vertex here. If my vertex is there, that also means I would have an axis of symmetry dropping through there. So without doing any formulas or math, I can find my axis of symmetry is x equals -3. So here we go. And without doing anything else, I can actually tell you, because I can visualize my graph opening downward, that we have a maximum value, and that max y value is at 5. Now, I think some of us see it better when we graph it. So how am I going to graph it? I'm going to create a t-chart with an xy. I'm going to put my vertex in the middle at -3, 5. And I'm going to go ahead and pick some values below that and some values above it, to the left and right of it to help me out. So how am I putting this in my calculator? I am going to take that -5. I'm going to just enter this in. So I'm putting this in. I've got my -2 parentheses -5 plus 3. Try that again. Quantity squared plus 5. And I hit enter and I get out -3. Now to save myself time, I'm just going to arrow back up and I'm going to change out my numbers So I have a positive 3, change that out to skip over to negative 2, and change that out to negative 1. And from here, I'm going to go ahead and be able to graph this. So I've got my negative 5, negative 3. I'm going to plot a point at negative 4, positive 3, negative 2, 3, and negative 1, negative 3. So again, not the most accurate graph, but good enough for what we're doing. And now that I have that graph, I can see that max value at 5. And the other thing I want to talk about is my domain and my range. So even though my graph opens downward, I can see that this is going to get wider. Okay, even though it's a more narrow graph, it's still getting wider, so negative to positive infinity. The range has a high at 5, but the low is negative infinity. So interval notation, we always start with the low, and we stop at the high value with a bracket.